Now let's proceed to section B. In section B, we have 2 marker questions. तो ये पहला सवाल है section B का, that is question number 21. It states, show that these 3 terms are in AP. जब कभी भी AP के terms की बात करते हैं, we have the same common difference between 2 consecutive terms of an AP. So, if these 3 terms will be in AP, then difference between these 2 terms will be equal to difference between these 2 terms. So, let's take that into consideration. Now, here I am considering difference of first these 2 terms, where I'll be taking up a square plus b square, and from that I'm subtracting a minus b whole square. Let's simplify this one. Here it results a square plus b square minus, and on expansion this will give you a square plus b square minus 2ab. When you will open up the bracket, it results here a square plus b square minus a square minus b square minus minus plus 2ab. You can clearly find that plus a square minus a square and plus b square minus b square gets cancelled, and this becomes equal to 2ab. So, I can definitely say that difference of these 2 terms is equal to 2ab. So, I can write here a square plus b square minus a minus b whole square is equal to 2ab. Let me consider this as equation number 1. Now, proceeding further to difference of the other 2 terms. Here I have a plus b whole square minus, I am considering a square plus b square, where you can simplify this further. This is a square identity, where on expansion of this it is going to result a square plus b square plus 2ab, while here in the bracket we have these 2 terms, a square plus b square. When you will open up the bracket, here it results a square plus b square plus 2ab minus a square minus b square. And you can clearly find plus a square plus b square minus a square minus b square gets totally cancelled. And here I am left with the term 2ab. Now, here this gives me a clear idea that in this case, when I am considering a plus b whole square minus a square plus b square, this is equal to 2ab. Let me consider this as equation number 2. When I am considering equation 1 and equation 2, you can find difference between these 2 consecutive terms is same. That means this common difference is uniform. These 3 given terms are definitely in AP. So next I can definitely conclude that from equation number 1 and 2, we get, from 1 and 2 we get that a square plus b square minus a minus b whole square is equal to a plus b whole square minus a square plus b square. That means their common difference are equal. So you can further definitely state here that their common difference are equal. As their common difference are equal, that means the 3 given terms are definitely in AP. I could write here that, hence, the 3 given terms a minus b whole square, a square plus b square and a plus b whole square are definitely in arithmetic progression. They are in arithmetic progression. I hope this question is clear to you. So this was a 2-marker question, and in this question, when you have firstly taken the difference of the second and the first term, you have expanded this identity till the step you will get half mark. And when you have obtained the difference of the first 2 terms as 2ab, in this step also you will get half marks. The similar thing is obtained in this case also, and in this step you will obtain half marks. And finally, when you have concluded the result from equation 1 and 2 that their common differences are equal, and in this step you will get further half mark. So in this manner you will get total 2 marks for this question. I hope that's clear. Now let's proceed to question number 22. Here we have the question number 22. You can clearly see we have an option in this question. So in the first part of this question number 22, we are solving a question related to triangle, and in its option also we have a question related to circle. You can see these are entirely two different topics given in the option. Either you can answer the question related to circle or you can answer the question related to triangle. It's up to you. So let me solve the first part of this choice for you. So in this question, it has been stated in the figure 2, D is parallel to AC and DC is parallel to AP. Prove that BE upon EC is equal to BC upon CP. So in this question, we are talking about the set of parallel lines, and whenever you think about the set of parallel lines, the most important thing that comes to your mind is basic proportionality theorem. So here we have obtained a set of parallel line. You can see DE is parallel to AC. If I consider here just this triangle BAC, D is parallel to one of its side AC. So basic proportionality theorem can be definitely applied here. And you can easily apply here basic proportionality theorem, which will give you this result. You can see that as we have DE parallel to AC, I will be getting that ratio of these two sides BE upon EC is equal to BD upon DA. You can clearly see I have obtained this by BPT. This is equation number 1. The second thing which has been given in this question is DC is parallel to AP. So here also basic proportionality theorem can be applied. You can see that DC is parallel to AP. If I consider this larger triangle BAP, then this will definitely give me the result that BD upon DA is equal to BC upon CP. So next I get from triangle BAP, where DC is parallel to AP, BC upon CP is equal to BD upon DA. So I have here two equations, equation 1 and 2. You can clearly observe equation 1 and 2, their right hand sides are equal, that is BD upon DA. So I can definitely conclude here from equation number 1 and equation number 2, we get that their right hand sides are already equal, so their left hand sides will be also equal. I get clearly B upon EC is definitely equal to BC upon CP. And this is the required condition to be proved. And you have clearly proved over here that B upon EC is equal to BC upon CP. So in this way, you have proved the required result. So this was a 2-marker question where till this first equation where you have applied basic proportionality theorem, you will get half marks. And in the second equation, on obtaining through BPT, you will get again half mark. When you equate equation 1 and 2 after identifying their RHS are equal, you will get again half marks till this step. And finally, when you conclude the required answer, you will get more half marks. So, half into 4, you get total 2 marks for this question. I hope this is clear. Now we have the choice in this question. Let's come to the second choice of this question number 22. This is a question related to circles. Here it states, in figure 3, two tangents TP and TQ are drawn to this circle with center O. And you can clearly see they are drawn from this external point T. Next, you have to prove that angle PTQ is equal to twice of angle OPQ. So let's proceed with this question. Very first, you can observe here O is center of the circle and OP is joined with the center. So OP is radius. In similar manner, here OQ will be also radius. So firstly, I'll be doing a construction. I'll join here OQ. After joining this OQ, you can clearly visualize that this gives me this triangle POQ, which will be an isosceles triangle. Why? Because its two of the sides are equal. You will definitely get OP will be equal to OQ. So I definitely get that OP is equal to OQ, and when two sides are equal for a triangle, the angles opposite to these equal sides will be also equal. That gives me this angle. OPQ is equal to OQP. So as I have obtained these two equal angles, let's take angle sum property in this triangle POQ. After taking angle sum property in this, I obtain that angle OPQ plus angle OQP plus angle POQ is equal to 180 degrees. So as OPQ and OQP both are equal, so this could be simplified and written as twice angle OPQ equal to 180 degrees minus angle POQ. Why? Because we have transposed angle POQ to the right hand side. So this gives me here first equation. Next, let's come to this figure again. Here you can clearly observe that OP and OQ are radii to the tangent, and radius is always perpendicular to the tangent at the point of contact. So I'll definitely get this angle TPO and an angle TQO equal to 90 degrees. Let's take angle sum property in this quadrilateral TPOQ. So I can write next, in quadrilateral TPOQ, I get here angle PTQ plus angle TPO plus angle TQO plus angle POQ equal to 360 degrees by angle sum property of the quadrilateral, where these two angles are measuring 90 degrees. Let's substitute that here. I get here angle PTQ plus 90 degrees plus 90 degrees plus angle POQ equal to 360 degrees. So this will get further simplified as 90 plus 90 gives me 180, which gets transposed to the other side and gives you a simplified value for angle PTQ equal to 180 degrees minus angle POQ. Let's consider this as equation 2. Now I want you to observe equation 1 and equation 2. In equation 1 we obtain twice angle OPQ is equal to 180 degrees minus angle POQ, and equation 2 I obtained angle PTQ is equal to 180 degrees minus angle POQ. So clearly their right hand sides are equal, which implies their left hand sides will be also equal. So next I could write here, from equation 1 and equation 2 we clearly get here that angle PTQ is definitely equal to twice angle OPQ. So this is the required result to be proved. Hence we have proved here the required condition. So you can definitely mark here the answer for this question is this. So we have proved this condition, and this was a 2-marker question. When you obtained here equation number 1, till this step you will obtain 1 mark. Here we will get half marks for this condition for proving these two angles equal, and half marks till equation 1. That gives me total 1 marks till equation 1, and next you are going to get half marks for equation 2, and finally on comparing 1 and 2 and obtaining the required result you get rest half marks. That gives you total 2 marks for this question. I hope that's clear. Let's proceed to our next question.